Hello and Assalamualaikum. Today we will learn about a new section which is 10.9. The title is Linear Constant Coefficient Differential Equation. The short form is LCCDE. So we will learn about the first part first, which is homogeneous differential equation. So what is homogeneous? This is the form of homogeneous differential equation. And if the right hand side has any function, it is non-homogeneous. Okay. So that is the brief explanation about that. And I want to explain to you what is the meaning of constant coefficient. So what is constant coefficient? Now we will go to the first order linear homogeneous constant coefficient equation. So we will look at the first order differential equation first. So let's say A so A dx dt plus b x equal to 0. So this is the first order. Why? Because the derivative is in the first order. So we need to make sure that a is not equal to 0 in order to make it a first order. So how to find the solution of this equation, or the general solution? So we need to find, we have the formula for that. So we want to change this form into, we can change this form into a characteristic equation. So what is the meaning of characteristic? So again, I want to repeat, this is the first order. So characteristic, remember this function or equation. Actually it's the same. So we just convert this equation into this form, where a dx dt we change into m, and plus b, x we just equal it into 1. So this is the form, and we can find the solution. We can find the value of m if we know the value of constant a and constant b. Okay, now I want to explain what is the meaning of constant coefficient. So this a and b are the constant coefficient, which means the value is not changing. Okay, so that is the meaning of constant coefficient differential equation. Okay, so now I can find the value of m. So m is equal to negative b over a. Okay, so from there we can find the solution. The solution is, this is the formula for first order. Okay, so this is the solution for the differential equation given above. Alright, so you can memorize it if you want. Okay, now that is for the first order. Now we go to the second order. Second order differential equation. So the general form for the differential equation is like this: d2x dt2 plus b dx dt plus cx equal to 0. And a should not be equal to 0 because we want to make sure that this is second order. Okay. And again, we can convert this into a characteristic equation. So this equation is because previously dx dt is equal to m, so d2x dt2 is equal to m squared. So I change it to this form. bx plus c equal to, I'm sorry, this is m. Okay, equal to 0. So from this quadratic, this is a quadratic equation, we can find the root of this equation, or the solution of this quadratic equation. So we know that we have learned about quadratic equation, and there are 3 types of root that we can have from a single quadratic equation. It can be 3 types, which is the first one is 2 real and distinct solutions. So this is the first one. The second one is, and again, when we have quadratic, usually, not usually, we will have 2 roots. Okay, if it is for cubic, for example, if for cubic equation, we will have 3 roots. For quadratic equation, we will have 4 roots. So for quadratic, we have 2 roots. So we also have a condition, which is the 2 roots are, maybe I just write root right here. Okay. So 2 similar real root. Okay, and the last one is 2 complex roots. So for the complex root, I can give the form is like this: psi plus minus j. Okay, so if we get these roots, what will be the general solution for this differential equation? So what is the solution is, the first one, if we have 2 real and distinct roots, so this is the solution. A is the constant, we can find it. So m is, in this case, is the root. M1 is the first root and M2 is the second root. So plus B E M, the second root, T. So this is the general solution if we have 2 real distinct roots. Okay. If we have similar roots, what will happen is we still have 2 constant, but we add T at the first constant, plus B E M T. Okay, so M is the similar roots. Okay, now we go to the third type of roots. So X T is equal to A cos, I don't know what is the symbol, T plus B sine t. So let's say I name it omega. So if we have this kind of root, we will have this kind of a general solution. But wait, I need to add the exponential part component. Okay, so the psi right here, the psi go to here, and the omega go to here, right? Do you understand that? So this is the formula that you need to remember. This one. Alright. So in order to further understand this concept, we will go to the example in this section. So we go to example 10.34. Actually, example 10.34 is for this one. 10.35 is for the complex root, and 10.36 is for the similar real roots. Okay. So we just go to the example briefly. So we need to find the general solution, GS. I give a short form of. So this is the question. Okay. So we can change into the characteristic equation. So characteristic, I just simplify the word characteristic equation. So we change again, remember, we change this into m square, we change this into m, this one is, we change into 1. Okay. So what will happen is m square minus 9m plus 6 equal to 0. If you remember, in order to find the roots, there is a popular or famous formula, which is this one. So you can find this m by using this formula. So after you find the two root, you can see whether it is two similar root or two different but real root, or two different but complex root. Okay. So remember this formula. So from this example, we found that m is equal to 4.5 plus minus 1/257. So we have two real roots, two real but different root. So the first one is, from here we get m1 equal to 8.27, we get m2 is equal to 0.73. Therefore we get the solution. We just put this value, we use the formula. We use the formula right here. That one, and put the value of root. Just ignore the constant a and b. So we just put the constant a, 8.27 t, plus b e exponential 0.73 t. So that is the solution for this example. Okay, the general solution. Okay, now we go to the next example. 10.35. So find general solution of different equation d2 d2 dt d2x dt2 minus 3 dx dt plus 5x equal to 0. Okay, again remember when it's equal to 0 it's homogeneous. So now we find the first thing, we need to find the characteristic equation. Okay, so we have 2m square minus 3m plus 5 equal to 0. So again we use the formula again, this formula to get the roots, to find the roots. Okay, and we can find that m equal to 1/4 3 plus minus j 31. Okay, so now therefore m1 is equal to 0.75 plus j 1.39, m2 is equal to 0.75 minus j 1.39. So we have complex roots. Therefore we use the third formula. Alright, so we can find the general solution. Xt is equal to e power of 0.75 t a cos 1.39 t plus b sin 1.39 t. Okay, so the difference is I put the exponential at the beginning instead of at the end. Okay, so this is the solution for the example 10.35. Now we go to example 10.36. Okay, so we need to find again general solution of d2x dt2 plus 6 dx dt plus 9x equal to 0. And in this equation we are given the boundary condition. So sometimes we will be given with boundary condition. So what is the use of this boundary condition? I'll tell you after this. So now focus on the differential equation first. And again, first of all, we find the characteristic equation. So m square plus 6m plus 9 equal to 0. So we use the formula again to find the roots. And when you find it, you can see that the root is similar. We have similar repeated root. M equal to -3. So we use the second formula right here. Okay. So therefore x t, so this is the general solution, a t plus b e -3 t. This is the root. Okay. So now, what is the use of this constant? Since we know the formula already, the answer, but since we are given with the boundary condition, we need to put the value of the boundary condition inside this equation to find the value of constant A and B. Okay, so when we consider that we put the value t is equal to 0, x is equal to 1, and then afterward we differentiate this one. Let's say we try to differentiate it, we will get okay, so at negative 3e negative 3t plus a negative 3t. So this n minus 3b e negative 3t. Okay, so this is the derivative. So when t is equal to 0, right here, when t is equal to 0, dx dt will be equal to 2. So you just put the value, t is equal to 0, dx dt is equal to 2. So when we compare these two equations, after we put the value, we can find the value of a and b. You can do that by yourself, and we can find that a is equal to 5, b is equal to 1, and therefore we can find the no longer the general solution, but the solution itself, which is xt is equal to 5t plus 1 e power of negative 3t. Okay, so this is the solution for example 10.36. Okay, so hopefully you understand